Stop when you are ready. Yeah, stay in the video. Yes, that's right.
Hi everyone, my name is Nattida. Today I'm going to present the research of backflash over performance from physical properties. So I divide my presentation into 5 sections. The first one is motivation. I will tell you about what is backflash over and what is shooting failure. And the second one is problem statement. The third one is proposed solution by extreme gradient boosting and cadence algorithm. And the fourth one is results. And the last one is conclusion. But today I will tell only motivation and problem statement. Okay, first let's start with motivation. From all past 10 years between 2011 to 2020, this figure shows that the common cause of failure of high voltage transmission line is like top 3 is animal, tree, and you see that the most common cause is lightning. So we can categorize the lightning strike that cause damage to transmission towers into 2 ways. The first way is backflash over, and backflash over is occur when the lightning strikes on the overhead ground wire, and then the voltage exceeds the durability of insulator from high ground resistance, and then flash over is occur. But in another way is shooting failure. Shooting failure occurs when the lightning strikes on the conductor and then the voltage exceeds the durability of insulator and then flash over is occur. You will see that this difference is only where the lightning strikes on. But in this research, we will consider only backflash over because it have a chance to occur more than shooting failure. So next, let's talk about problem statement. But first, I will tell you about TLAs. TLAs. This one is TLAs. TLA is transmission line arrestor, and it used to divert the high voltage lightning strikes to the ground, and it can prevent damage to the equipment like transmission line. Transmission towers. Yes. So, but TLA we have a limit quantity, so we have to. The problem statement of this research is we have to finding an algorithm to reduce the time to select the appropriately high voltage transmission tower to install TLAs that we have limit quantities. So, but we will considering by the risk of backflash over only. So we consider the risk of backflash over by 3 physical properties. Like the first one is types of transmission towers, and second one is the soil scar resistant value at the tower's location, and the last one is the kind of location where the tower is located. So that's all for today, but next week I will tell you other sections. Thank you.
Okay. Yes, question please. High voltage.
What is the more, I mean, what is the worst case about if the backflash over and what's another thing, backflash over and the sharing failure? What is the most downfall between
Could you repeat the question first?
What is the most damage is backflash over and shooting failure? I think the transmission line is damaged. So like by down like yeah. Yeah, we can use we can use the electric. Yes. This is a high voltage transmission line. It used to transfer the electric to another place. So if it damaged, it can transfer.
Yeah, good. Baba,
Please next slide. So TL is working like a thing. TLA.
Arrested.
Yeah. So TL is directly going to underground, right? What they are thinking. Understand? So TLA is working like a thing or grounding. TLA.
so the question is about the TLA.
Yeah. Is used for their thing, like maybe when the directory search come,
Yeah.
is used for the TLA used for the search to control their thing, right?
Used to
And what is the question? And what is the
Yeah,
one more time,
basically
please?
TLA is is equal to a thing. Maybe we have to use for the grounding. If someone sudden any search, we have to use TLA for this purpose.
Yes. And what is the question?
Yeah, question is how many feet you have land you have to use undergrounding for the
oh like how what number of QA?
no TLA is going to directly go to underground.
What is it? The question is about the how to
Basically, the
design.
question is about the how many bits we have to use underground for the
How many? How do you know how many
How many
TLAs?
TLAs you use in one line,
Yeah.
right? Actually, it depends on what they given. Actually, if you have TLA, if you have many TLA, it will be better. But basically, it depends on what how many like 10 TLAs. It is from like EGAT, from EGAT Thailand. Yes, but no requirement. But if you have many TLAs, it would be better.
So like any like engineering criteria for like a high voltage or the power system when you design this kind of thing. How do they know about the TLAs?
depend on the distancing and the distancing between the tower, two towers.
Is there kind of like a standard recommendation that engineers use in the field to design or the proper number of the TLAs to be used or something like that?
Oh, but we have a condition like you have to install TLAs two towers together, like two. But the algorithm I will tell you next week.
Okay, good. Any last question? Yes.
So in the traditional, this study is to improve the TLA to reduce the time.
Yes, because
What is the question?
Why is important to reduce the time?
because now we use program. If program is like a TW Gen 2, this used to find the risk of backpatch over, but it take more time, like 10 hours to predict how.
And 10 hours, does it matter when you want to invest in the design of this high voltage transmission lines? if it's going to take 10 hours for compute the design, or it's going to take even 1 month to compute the design, so what?
But we have many lines in Thailand. So I think my algorithm can be similar to this model.
I think that is your question, right? Why do you have to care about the computational time? Right?
So the time is not the time of all.
That time like how
Time to compute, right? Time to compute for the design. Okay, good question. Yes. So thank you very much, Nattida. Wow, you can see. Oh, I have to check actually if I have